All right, here we go for part two, folks. Um, Lots of stuff to read there. You can read the question. I'm not going to read it to you. But when you get into it, the biggest thing is when there's so much information, start a diagram and see if we can figure out what's going on. So we've got a street here with some lots, rectangular lots. And it says each lot must have an area of 405. So each of these is 405, right? Meters squared. And that's given. So that's also given. So the area is 405. That's given. Area of one of these is given. And then there's a bunch of information about the cost of the fencing. And I'm going to put this in a different color. Again, we've got one of these diagrams where there's two things on the same diagram. We got to be very careful that we don't, when I write the front fencing cost 20 meters, this stuff is, or $20 per meter, that I don't think that this is 20. It's not. It's $20 a meter. Okay. The two side fencing for the two outer sides, this is 15 over here. This is 15 over here. The interior and rear line fencing is 10 bucks. That's per meter, right? So each of these is 10 bucks a meter as well. So what shape for the lots gives a minimum fencing cost. So what are we after? What's required? We want to find shape, so the dimensions, to minimize the cost. Minimum cost. Okay, well let's come up with a cost function. First of all, we got no variables here. So why don't I call, just for funsies, I'll call this little piece here X. It's important to choose what your variables are wisely. If I called this whole thing X, then each one of these would be 1/3 X, and I'd be dealing with fractions, and that would be much more difficult. But if I call each of these X, then I can talk about the bits and pieces better. I'm going to call this all these pieces are Y here, and then the cost. If I start talking about the cost, I can break it up into pieces here. So the cost, let's say the front first. Well, each of these is X, and they cost $20 a meter. So if this is X meters, then this is 20X, 20X, 20X. That's 60X. Plus, let's say, what do we got? The sides is 15Y and 15Y. That's 30Y altogether. Plus the inside. We could put the inside and the back together, I suppose, but that's inside and inside is another 20Y. Plus the back is 10X, 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 30X altogether. Collect those up. And I got 90X plus 50Y, but I'd like to take the derivative, right? The minimum occurs when the derivative is equal to 0, but I've got two variables still here. Well, how do I get rid of one of them? There's all sorts of different things. I haven't used that yet, right? So the area here is 405, but I also know that X times Y is 405. So X times Y is 405, and I can solve for one of them and then substitute it in. I'll only have one independent variable, and off to the races I will go. All right, so just for no particular reason, I'm going to solve for Y here and then substitute in. Then I'm going to get, see, I solve for Y, so I take out the Y and I put in the 405X, and then this is the function now. Only one independent variable, I can take the derivative. By the way, this was all, this here was all my planning stage. All this stuff was my planning stage. Now I'm ready to take the derivative and set it equal to 0. So minimum occurs when C prime at X equals 0. Well, I'm going to tidy this up a little bit. get it ready to take the derivative. 50 times that, bing that into your calculator. Oops. 250, and I'm going to put x minus 1 like that, so that when I can take the derivative, it's going to be an easy derivative to take. So I got c prime at x is equal to 90 minus 20,250x minus 2. No chain rule because x is the independent variable and it's equal to 0 for the minimum. Solve this. I'm going to put that on the other side. The x is going to go down into the bottom for me. Cross multiply, right? Negative exponent means it's in the fraction. Divide by 90 on both sides. Square root. I can discard the negative, of course. This is whatever that is. I think that's 225. And so x is equal to positive and negative 15. But of course, the negative doesn't make sense. Discard x equals negative 15. And then check my endpoints if I wanted to, but I know the minimum is going to happen at 15. What would be the other possibilities? Well, x could be 0, right? I guess. Or it could be up to almost the entire thing. So what's the entire thing? Could x be 0 actually? No, not really. X has got to be greater than 0, but we could think of it as being the endpoint 0, because it could be 0.00001, teeny little width and a really, really long lot, I suppose. But we know that's going to be the minimum, right? Or the maximum cost. It could be, what could it be if it was just fencing along the sides here? Well, I suppose if I look over here, what would be the maximum value of x? Well, I guess x could be up to, well, x could be just about anything, I suppose, because y could be really, really, really small, but we might think of it maybe being something like 405. Could x be, no, it couldn't be 405. It could be 405 divided by 3. Oh no, each one of those, yeah, so sure. Could this be 405 and this be 1 meter? Maybe, but that seems a bit silly. It's going to be pretty expensive. We know that these will give the maximum costs here. So again, dismissing those a little bit. But here, what's the cost? You put that into your calculator, back into the original function, and you get a cost of 2,700. So then, statement, a minimum cost of 2,700 bucks occurs when the lots are 15 meters wide and 405 divided by 15 is equal to 27 meters long away from the road. Okay, dandy. We got one more example? We do. Oh, and this one looks okay, although there is some weirdness, I promise. Apple Appliances can sell X hundred wood-burning stoves. So this is what makes this one weird, is this X100. What's up with the X100? Second time here. You know what? I'm going to pick up example 3 in part 3.